So we left off with setting up our player's input. So we are getting input now, but we never filled out our player movement script. So in this video, we'll go ahead and we'll take care of filling out that script. So first, we're going to go ahead and drag that script onto our player just to make sure that it is attached. And then we'll go ahead and open that up. All right, so first thing we're going to do is we're going to go ahead and just remove a couple of these things that we're not going to need in the script, just to clean that up a little bit. So we're going to want to set up a couple of variables here. The first one is going to be a rigid body 2D, and we're simply going to call that RB for rigid body. And then we're going to need a few serialized fields here. First one is going to be of type float, and we're going to call this one move speed. And I'm going to set mine by default to 5F. And then we'll need another float here, and this one is going to be our acceleration. And I'm going to set mine to 10F by default. The next thing is going to be our deceleration. And again, this is going to be another serialized field, and this is also going to be a float. And this is going to also equal 10. Next, we're going to need another serialized field, and this is going to be a float as well. And this one I'm going to call jump force. And I'm going to set this one to 10F as well by default for now. And we'll need one more serialized field here, or one more float. And this one is going to be called, we'll call it our air control factor. And by default, I'm going to set mine to 0.5F. And so these are going to be, this is going to be for our speed, for how fast we accelerate and decelerate, for how much force we're applying when we're jumping up, and then our ability to actually control our player while we're in the air, while we're jumping. So we're going to want another serialized field here, and this one is going to be of type layer mask, and this is going to be our ground layer. And we'll want another serialized field, and this one's going to be of type transform, and this is going to be our ground check. And then for that, we're going to need one more serialized field here, and this is going to be of type float. Oops. And this is going to be our ground check radius. And by default, I'm going to set that one equal to 0.2F. So this is just going to, we're going to assign our ground layer to this one, and then this is going to be a ground check. So we're going to add in an object underneath the player to check if the player is actually touching the ground or not. And then this is just the radius of how far we're doing that check. All right, and then we'll still need a couple more. This is going to be a little bit of a longer script here. And this one, this one's going to be of a type float, and we're going to call it coyote time. And I'm going to set mine by default to 0.2F. And then we'll need one more serialized field, and this is also going to be of type float. And this is going to be our jump buffer time. And by default, again, I'm going to set that one to 0.2F. So this coyote time is going to be like a small grace period for jumping after we leave the ground. And then this is going to allow a small window to buffer a jump input. And then we're going to need a couple more, but these ones are not going to be serialized fields. So the first one's going to be of type float, and this is going to be our move input. And then we're going to have a bool, and we're going to tell if we are grounded or not. So is grounded. And then we're going to have another float. And this one we are going to call our last grounded time. And then the last one here is going to be another float, and this one we're going to call our jump buffer counter. So this is the move input. We're gonna get this from the input manager script. Is grounded. We're going to be determining whether or not the player is grounded or not. So if they're not grounded, they're not going to be able to jump again. And then our last grounded time here is going to track the last time that the player was grounded. And then the jump buffer counter is going to track the buffer time for jumping. And then the last thing that we're going to need to do here before we start going into our methods is we're going to need a reference to our input manager script. So this is going to be of type input manager, and we're going to call it input manager. So the first thing that we're going to want to do is we're going to need an awake method. And in here, we're going to get a reference to our rigid body. So RB is going to equal our get component rigid body 2D. And then we're also going to want to get a reference for our input manager as well. So we're going to say input manager, and that's going to equal find object of type, not by type, of type, and of type input manager. So this is going to get the rigid body that's attached to the player, or the rigid body 2D that's attached to the player. And then this is going to create a reference to our input manager script. So we can use these here. So we'll go ahead and we'll work on the jump first. So what we're going to do is we're going to create a new method called jump. And in here, we're going to say rb.velocity, and that's going to equal new vector 2. And inside of here, we're going to say the rb.velocity.x, and then comma and our jump force. And then the last thing we'll have to do in this method is we're just going to say the jump buffer counter, and that's going to equal 0f. So here what we're doing is we're going to be setting the player's vertical velocity, so on the x, to the jump force, and then we're going to reset the jump buffer so the player doesn't double jump, or they're not able to continuously like double jump or anything like that. And for the jump to work, we're going to head up here back to update, and we're going to want to do a few things. So we're going to say is grounded, and that's going to equal physics 2D dot overlap circle. And here we're going to say our ground check dot position, and then our ground check radius, and our ground layer. So this here is going to check if the player is touching the ground by using the ground check transform. So in here, we're passing in our ground check dot position, which is going to be like the center of our empty game object that we're going to create here in a minute on the player. And we're going to put that at the bottom by the player's feet. And then here we have our ground check radius, which is going to be like the radius that's going to be used for detecting the ground. So how far of a detection area there's going to be around the ground check position. And then here our ground layer, which is going to be the layer mask that specifies which objects count as the ground. So we're going to assign our ground layer to our tile map, and that's going to count as the ground. Next, we're going to want to say if, and here we're going to say is grounded. And then here we're going to do our last ground time, and that's going to equal time.time. So this is going to help us in creating that coyote time, which is like a small grace period for jumping after you leave the ground. And we're going to finish setting this up here in just a moment. And next, we're going to want to say if our input manager dot jump input, and here we're going to say jump buffer counter, and that's going to equal time.time as well. And so this is going to be a buffer for our jump input. So it's going to allow the player to jump slightly before landing. So it's just going to make everything seem or feel a little bit smoother. And so then lastly, we're going to want one more if statement here. And this is where we're going to actually execute the jump if all of the conditions are met. So the coyote time that we created or grounded and jump was pressed. So we're going to say if our time.time minus our last grounded time is less than or equal to our coyote time, or if we are grounded, so or is grounded, and I'm just going to go to the next line here to make this easier to read, and time.time minus our jump buffer time is less than or equal to our jump buffer time. And this is not jump buffer time, this would be our jump buffer counter. Then we'll want to jump. So then we'll call jump. So to go over this to hopefully make it all make sense here, the first thing is, we're going to need to know if the player is on the ground. So that's what we're doing here in this section. And this line is going to check if the player is standing on the ground. And if they are, we're going to save that current time in a variable that's going to be called our last grounded time. And that way we know exactly when the player was last touching the ground. And next down here, we are going to want to give the player a little bit of forgiveness when they press the jump button. So whenever the player presses the jump button, we're going to save the time in another variable that's going to be called the jump buffer counter. And this is going to allow us to remember the jump input for a short period. So even if the timing isn't perfect, the jump can still happen. And this section here is where we're actually going to, to make the player jump. So it's going to combine two different things in here, the coyote time that we created and then jump buffering. So the coyote time, it's kind of like a little trick that lets the player jump even if they've just left the ground. So if you're just like happen to walk off a platform or something like that, it's going to make the game feel a little more responsive and give you a small window for jumping even after leaving the platform. So as long as the time since the player was last grounded is less than the coyote time, then we're still going to allow them to jump. And then for the jump buffering, that's going to give the player a little grace period if they press the jump button before they land. So even if they press jump slightly too early, it's still going to work because we saved the time when the jump button was pressed. So basically here we're checking two things. Has the player recently touched the ground? That's going to be the coyote time. And then did the player press jump recently? That's going to be the jump buffering. And as long as both conditions are true, we're going to call jump and the player will jump. So next we're going to actually make the player move. And for this, we're going to want to use fixed update. So first we're going to need to get the input from the input manager. So here we're going to set up our move input, and that's going to equal our input manager dot horizontal input. And so here we're just getting the horizontal input from our input manager script. And this is going to tell us if the player is pressing the left or right keys. And it's going to usually be a value between like -1 and 1. Negative is going to mean it's going left, and positive, it's going right. And 0 will mean that, the player isn't pressing any keys. Next up, we're going to set a float, and this one's going to be our target speed. And that's going to equal our move input times or multiplied by our move speed. So here we're multiplying the input by the player's move speed and to get the target speed. And this means that if the player is pressing right, they'll move at the move speed to the right. If they're pressing left, they'll move at the same speed but to the left. So next we're going to do a couple lines here so we can make the player's movement feel smooth and not too sudden. So here we're going to have a float called the speed diff. And that's going to equal our target speed minus the rb.velocity.x. And then we're also going to want to do another float here. And that's going to be, we can call it our accelerate. So like our acceleration rate. And that one is going to equal mathf dot abs. And here we're going to take our target speed. That's going to be, if that's greater than 0 dot, we're going to use 0.01f. And then we'll put a little question mark here. And we're going to say acceleration, semicolon, deceleration, or colon, sorry, not a semicolon. So here we're calculating the difference between the target speed and the current speed. And since the player can't instantly reach their top speed and it takes time, so we use acceleration to speed them up when they're moving and deceleration to slow them down when they stop pressing the keys. That's what these are for. And this is going to switch back and forth between these depending on if we're, accelerating or decelerating. So here we're getting the acceleration rate. So this is going to be mathf.abs, which we're going to get the absolute value of the target speed. So this is always going to ensure that the speed value is always positive, whether the player is moving left or right, since negative values do represent moving left and positive values represent moving right. And then this this whole condition here is going to check if the player's target speed is greater than a small threshold, which we have set here, the 0.01f. And this is going to be used to avoid like a very tiny floating point inaccuracies and ensure that the script only considers like meaningful movement. So make sure that we're actually moving. So if our target speed here is greater than 0.01, it means that the player is actually trying to move left or right. And if it's less than or equal to 0.01, it means that the player has basically stopped pressing the movement keys and we should start slowing down or decelerating. And then here, this little question mark, like this is the condition, and then this is the value if it's true, and this is the value if it's false. And this is called a ternary operator. So what this is doing, we're basically checking if this part's true before the question mark, and if it is true, then we use this value, and if it's false, we use this value. So if it's true, we're accelerating. If it's false, we are decelerating. And the next thing that we're going to do is we're going to actually make the player move. So here we have float movement. And that one is going to equal, here we're going to do mathf.sign, and we're going to pass in, not movement, the speed diff, and we're going to multiply that one by mathf.min. And again, here we're going to use the mathf.abs for absolute, and we're going to pass in the speed diff. And then we're going to do the accel rate, and we're going to multiply that by our time.fixed delta time. All right, so here we're using the mathf.sign and the speed diff here to figure out which direction the player should move. So if the difference is positive, then the player's going to move right. If it's negative, they're going to move left. And since we don't want the player to change speeds too quickly or anything like that, that's why we're going to use this mathf, this one here, the mathf.min, and this is going to limit how fast they can speed up or slow down. This makes the movement feel kind of smooth and natural. And then finally, we're going to apply the movement in the correct direction by multiplying the speed difference by the result of our calculation. And this is going to ensure the player moves smoothly, whether they're speeding up or slowing down. Next, we're going to set up our air control. And so this is going to be float air control, and this is simply going to equal is grounded. And here we're going to do another ternary operator, so question mark, we'll say 1f, and then a colon and the air control factor. So what we're doing here is we're setting up our air control, and basically this is another ternary operator like we mentioned. So if this is true, we're going to be using this value here, and if it's false, we'll use the value on the right. So basically, if we're grounded, then the air control is going to be set to 1f, so the player's they're gonna have full control over their movement if they're on the ground. And then if they're not grounded, so if they're jumping and they're in the air, then the air control is going to be set to our air control factor, which I believe we had set to 0.5f here. So they won't be able to move as much when they're in the air as they can when they are grounded. And the last thing is to apply all this to the rigid body's velocity. So rb.velocity, and that's going to equal a new vector2. Oops. And this will be our rb.velocity .x plus our movement. And we're going to multiply that by our air control. And then we're going to say comma rb.velocity.y. So this line here is how we're actually going to apply the movement to the player. So first we're going to set up create a new vector2 to set the player's velocity. And that's just, how fast the player is moving in any direction. So for our horizontal movement, that's going to be the first part here. So on the left side of the comma. So we're going to take our velocity.x, and then we're going to add in our movement based on the player input, and then multiply that by our air control. So if the player is in the air, then we're going to multiply it by that 0.5f. Otherwise, it's going to be multiplied by 0.1 or by 1. So it's just going to stay the same. And then our vertical movement, it's always going to be the same here. That's why we just put in rb.velocity.y. So with that done, we can go ahead and head back into our editor now here, and we have the script attached. So first things we need to do is we need to set up our ground layer. So we'll click the layers, and we'd already set this up in a previous video, but if you don't have it set up, you click add layer and you can just add in a ground layer here. But we'll go ahead and select ground, and then we need to add our ground check. So for our player, we can simply right click our player and create an empty. And if we zoom in, we'll see the empty here. So we can drag this down to the bottom towards like the player's feet. And I'm just going to rename this to ground check. And then we can simply drag the ground check in here. So that's going to be used as the ground check. And now if we click play, it's just going to drop because our player is not in a good position. So I'm going to scroll out quite a bit here and just pick a random spot like here for now and click play. So it wasn't quite high enough. So I'm just going to move the player maybe over to here someplace, and I'm going to copy the position and stop playing, and then go into the player and just paste the position in there, and then move him up just a little bit. So now when we generate the world, he should be at the top, and he should just drop down onto the world there, which is great. And so that's our player. And now if we click into the game, you can't see on the camera here. We'll fix the camera in a minute, but you can see that the player is moving, so we can move left and right. And if we press space, we can jump up and down. So we are moving. You'll see here that it seems to kind of get stuck a little bit. So we'll want to fix that. And I feel like the jumping is just a little bit too high. So we'll want to fix that as well. So for the player getting stuck, that one is a pretty simple fix. So I'm going to go ahead and create a new folder here, and I'm going to call it materials. And let's go ahead and actually create a 2D physics 2D material, and we'll call it no friction. And again, do the same thing. Just make sure these are both set to 0. And now we can drag this into our box collider 2D on our player. And we can also drag this into our tile map 2D on our collider there. And for the jumping, what we can do, I think I'm going to adjust the gravity scale, maybe double it here and see how that feels. So with those changes, we'll go ahead and play and see how we feel now. And again, like I said, we'll fix the camera in a different video. We'll make a follow camera and stuff like that. But for now, we can see right here as well, just fine. But we can move left and right. Still seems like it's getting stuck a little bit, so we'll want to fix that. But the jump does seem a lot better. I feel like that's a lot better for how we would want it to starting out for jumping. To fix the issue with our player colliding with the ground and kind of getting stuck there, what we can do is we can actually change our box collider to like a capsule collider, which is going to be a little bit better for us anyways. So we'll go ahead and select a capsule collider 2D here and just edit the collider and make it match our player a little bit better. Like so. And then we'll add that same no friction material onto here as well. And everything else we should be able to leave the same. And I'm going to go ahead and remove the component there of our box collider. And now we'll go ahead and press play and test that out here. So now moving along, we shouldn't really be getting stuck anymore. And this is, at the bottom here, you can see how it's kind of shaped like a U instead of a flat square. That's also going to help for when we're going over things like this. So that way the player, if they're running like this, they don't get stuck on here or anything like that. And this is just better off for players. So we're going to use this one going forward. So now we have our player getting input and actually moving and being able to jump. and I think everything looks all right. So I think in the next video, we'll probably work on our camera, and we'll get this set up properly, and probably get like an actual spawn point set up for our player as well here. So they spawn in a actual spawn point every time, and then we'll have that camera set up so we can actually view what it's going to look like in the game. So we'll go ahead and we'll work on that in the next video, but thank you for watching.